We are now moving to the final discussion for the part 2 of module 3, which will be about moles. Mole is the counting unit for chemists. This is abbreviated as mol or MOL, all of it in small letters. Kindly keep that in mind. This is also a unit of measurement for the amount of substance that we are observing. 1 mole is 6.02 times 10 raised to 23 objects. You might be asking, why is it such a very big number? That extremely large number of a mole necessitates the extremely small size of atoms and molecules. Remember that atoms are very small, they are indivisible, so using the measurements like the metric system or the English measurement system, for example, meters, inches, pounds, kilograms, cannot justify the measurement of these atoms and molecules. So chemists and scientists came up with this number, which is called the Avogadro's number. Okay, mole is related to Avogadro's number, which is the name given to the numerical value of 6.02 times 10 raised to 23. Mole can be defined, or we can use the unit of measurement of objects, molecules, atoms, formula units, okay, in explaining or in describing the Avogadro's number. The Avogadro's number was discussed by Lorenzo Amadeo Avogadro. He was the one who discovered or who figured out the Avogadro's number. Again, when we say Avogadro's number, something that should come up with your mind should be 6.02 times 10 raised to 23 objects. Let's proceed with the problem solving involving the moles and Avogadro's number. For the following problems, we have to calculate the mole of a given substance. For this one, our problem states that how many objects are there in a 0.26 mole of glucose molecules? So what we're looking for here is objects. You have to always keep in mind that 1 mole is equals to 6.02 times 10 raised to 23 objects. And this number is what we call the Avogadro's number. So first, let's write what the given is. So we have 0.26 moles of glucose. And what we're looking for is its object. So let's multiply it, simply multiply it by 6.02 times 10 raised to 23 objects. We all know that this is equivalent to 1 mole of glucose. So all you need to do is do simple math, use your calculator, cancel out moles of glucose, and then you multiply 0.26 by 6.02 times 10 raised to 23 objects. And then your final answer should be 1.5652 times 10 raised to 23 objects of glucose. This is now your final answer. Okay. Let us now proceed with our next problem. In our next problem, we have to determine the number of atoms in a 6.5 moles of iron. So again, another reminder, Avogadro's number is equals to 6.02 times 10 raised to 23 objects, and that is equivalent to 1 mole. Let's start by writing the given, which is 6.5 moles of iron. So this is 6.5 moles of iron. Okay, and what we're looking for is number of atoms. Kindly do not confuse yourself with this one. Avogadro's number can be expressed in different units of measurement. So we can have it as objects. We can also call it as atoms. We can also call it as molecules. And we can also call it as formula unit. Okay, all of these four units of measurement are used to describe the Avogadro's number. So you just have to improvise. So we have here, since we're looking for the number of atoms, you have to multiply it by 6.02 times 10 raised to 23 atoms. Again, interchanging this 4 does not affect the value of the Avogadro's number. Okay? And then you have to, this one is equivalent to 1 mole of iron. Okay? And then proceed with the calculation on your calculators. You have to cancel out moles of iron and then simply multiply 6.5 times 6.02 times 10 raised to 23 atoms. And your final answer should be 3.913 times 10 raised to 24 atoms of iron. Okay? Again, we'll be using the unit of measurement, which is atoms, because that is what we are looking for in the problem. Let's proceed with the next problem for the solving of moles. So we have here the problem. There is 2.1 times 10 raised to 22 formula units of sodium hydroxide. It says here that we have to calculate the number of moles present in the given. Okay, so in here we're looking for the number of moles, quite opposite to what we were doing a while ago, because in those problems, in the first two problems, we are looking for either the formula unit, objects, or molecules. Okay, for this one, it's the opposite. So let's first write the given, which is 2.1 times 10 raised to 22. Formula unit, for this one, I'll just write it in shortcut form. Formula units of NaOH or sodium hydroxide. This one will be multiplied with this conversion unit. We have 1 mole of sodium hydroxide or NaOH. 1 mole of NaOH is equals to, okay, the Avogadro's number, which is 6.02 times 10 raised to 23 formula unit. Okay, since the given is formula unit, we have to use formula unit on this one. You have to remember that the Avogadro's number is flexible. Okay, it can use different units of measurement. So it can use objects, it can use atoms, it can use molecules. Okay, it can also use formula unit. Okay, that's why we're going to use formula unit in this one. And then you can proceed with your solving. Of course, you have to cancel formula unit and then proceed with solving. So since this is 2.1 times 10 raised to 22 and then you multiply it with 1 mole, you just retain. So this is just 2.1 times 10 raised to 22 moles of, so 2.1 times 10 raised to 22 moles of NaOH. And then you have to divide it by 6.02 times 10 raised to 23 23, because you already canceled out formula unit. And then using your calculators, you can proceed with the answer. So your final answer here should be 0.03488,372. Okay? Since the answer is very long, you have to round it off by two significant figures. Okay, round it off by two sig figs. And since we're referring to significant figure, it should be up until here only. So we have to cancel the rest of the numbers. Make sure that you are following the correct rounding off numbers. Your final answer here should be 0.035 moles of sodium hydroxide. This should be your final answer. Let us now proceed with molar mass. Molar mass is mass in grams of 1 mole of any pure substance. The unit of measurement that we use in representing or expressing molar mass is grams per mole. And we get molar mass by following this formula, which is number of moles times the number of grams per mole is equals to molar mass. For us to be able to understand this one better, here is an example. We have the compound carbon dioxide or CO2. Carbon dioxide has the formula mass of 44.01 atomic mass unit. You might be familiar with it. This is the total sum of all the formula unit of the elements involved in the compound. And this one is equivalent or is equal to 1 mole of carbon dioxide. It can also be the opposite. 1 mole of carbon dioxide is equals to 44.01 atomic mass unit of carbon dioxide. Okay? Their only difference is that their unit of measurement, but they have the same value. Let's proceed with the sample problems involving molar mass. For the first one, we have the problem wherein chromium is a transition element used as a coating on metals and in steel alloys to control erosion. Calculate the mass in grams of a 0.0250 moles of chromium. Says here round off the answers to two significant figures. Okay? So here we're looking for the mass in grams of chromium. Okay? In which the given is 0.0250 moles of chromium. So how do we solve for this one? All you need to do is you simply have to multiply it by, okay, we simply have to multiply it by the atomic mass of the element given. So we have here chromium, which has the atomic mass of 52. Okay, so it's 52 grams of chromium. Again, 52 grams of chromium is equivalent to 1 mole of chromium. Okay, and then you proceed with solving. You have to cancel out the labels, and then you proceed with multiplying 0.0250 times 52, and that is equals to 1.3 grams of chromium. For the final answer, we have to round off the answer to two significant figures. So with our final answer here, do we have two significant figures? Do we have two significant figures? We have 1 and 3, which are non-zeros, so this is already correct. Okay, so our final answer should be 1.3 grams of chromium. Let's proceed with our next sample problem. Carbon monoxide is an air pollutant that enters the atmosphere primarily in automobile exhaust. Calculate the moles of a 73.1 gram sample of this air pollutant. Round off answers to two significant figures. So we have here our given sample, which is carbon monoxide. Okay, and we are to calculate for the moles of the 73.1 grams of carbon monoxide. Okay, and then for the final answer, we need to round it off by two significant figures. For our first step, of course, we need to write our given, which is 73.1 grams of carbon monoxide. And then we multiply it by what we are looking for, which is moles. So we multiply it by 1 mole of carbon monoxide over our molar mass. But since in our problem, molar mass of carbon monoxide is missing, okay, we have to solve for it. So how do you solve for molar mass? Again, it's very simple. Okay, you simply need to look at the atomic mass of each element involved in the compound and then sum them up. Say for example, for carbon, we have, looking at the periodic table, we have 12.01. For oxygen, we have 16. Simply add them all together. So we now have 28.01 grams per mole of carbon monoxide. Okay, this is now your molar mass. So let's put it in our equation. We have here 28.01 grams per mole of carbon monoxide. Okay, and then you have to cancel out terms. Let's cancel out grams per mole of carbon dioxide. Let's now write the molar mass, which is 28.01 grams of carbon monoxide. Okay? And then you start by canceling out labels. So we cancel grams of carbon monoxide. Okay? Then proceed with solving. So we have here 73.1 times 1 mole of carbon dioxide or carbon monoxide. So we still have 73.1 mole of carbon monoxide. Okay? Divide it by 28.01. And then kindly take a look at your calculators and try to solve it. Our final answer here should be 2.6097822221 mole of carbon monoxide. Okay? And then we have to take a look at this condition wherein you have to round off the answers to two significant figures. Okay? So we now have, for our final answer, we have 2.6 moles of carbon monoxide. Okay, does it now follow the condition that was given, which is two significant figures? Yes. So this is now your final answer, which is 2.6 moles of carbon monoxide. Let's proceed with our next example. The compound deoxyribose, or C5H10O4, is an important component of DNA molecules. How many moles of carbon atoms, hydrogen atoms, and oxygen atoms are present in a 0.456 mole sample of deoxyribose? For this one, okay, since we are looking only for the individual moles of carbon, hydrogen, and oxygen, all we need to do is multiply it by their subscript. First, we need to write the given, which is 0.456 moles of deoxyribose, or C5H10O4. and then multiply it by the number of carbons in the given compound. So we have the subscript 5 for carbon, so we only need to multiply it by 5 moles of carbon. And then proceed with multiplying using your calculator. Our answer here should be 2.28 moles of carbon. This should be our final answer. And then you can proceed with the rest. Same method that we will use for solving for the moles of hydrogen. We have 0.456 moles of deoxyribose or C5H10O4. Then you simply need to multiply it by how many hydrogen atoms are there in the compound. So in our compound, we have the subscript 5 for hydrogen. So we need to multiply it by 10 moles of hydrogen. So our final answer here would be, it's very easy, we have 4.56 moles of hydrogen. You see how easy it is solving for the individual moles of each atom. And then kindly pause this video and try to answer moles of oxygen atoms on your own. Okay, let's answer it all together. We have 0.456 moles of deoxyribose, which is C5H10O4. Multiply it by the number or the subscript attached to our oxygen. Okay, which is simply 4. We have 4 moles of oxygen in the compound given. Try to solve it. Hopefully we have the same answer. We have 1.824 moles of oxygen. This is now your final answer. So for this problem, since we're looking for 3 different quantities, which is the moles for carbon atoms, hydrogen atoms, and oxygen atoms, we also have 3 different answers. For our next and last problem, we have here acetaminophen. A painkiller has the formula C8H9O2N. Calculate the number of formula units of the pain reliever if given quantity is 4.5 grams. So for this one, we are looking for formula units of the acetaminophen. Our given is in grams. Okay? We cannot directly convert grams to formula units. So what we need to do is convert grams to moles and then to formula unit. Okay, with the use of Avogadro's number. So let's write down the given first. We have 4.5 grams, okay, of C8H9O2N or the acetaminophen, and then multiply it by the molar mass of the substance, which is the acetaminophen. But we don't have the molar mass given for this one. Okay? So molar mass is missing. So what we need to do is we need to solve for the molar mass first. So again, in solving for the molar mass, you first list down, okay, all of the elements given in the compound. So we have here for carbon, so we have here 12.01. For hydrogen, we have 1.008. For oxygen, we have 16.00. And for nitrogen, we have 14.01. We also have to multiply them by the subscript that they have in the given compound. So for carbon, we have to multiply it by 8. For hydrogen, we have to multiply it by 9. For oxygen, we have to multiply it by 2. And then for nitrogen, it's simply 1. Kindly solve this on your calculator and then come back for the final answer. Okay, so the final answer for the molar mass of acetaminophen is 151.162 grams per mole. Okay, so let us put it in our equation. Again, we have 4.5 grams of acetaminophen. So we have to multiply it so that we can convert it to moles. So we have 1 mole of C8H9O2N or the acetaminophen over the molar mass, which is 151.162 grams. And then you can multiply it to get the formula unit. So in getting the formula unit, we'll be using the Avogadro's number, which is 6.02 times 10 raised to 23 formula unit over 1 mole of acetaminophen. Okay, cancel out labels and then proceed with solving it on your calculator. Your final answer should be 1.7921170666 times 10 raised to 22. Let's round it off by 2 sig figs. Okay, round off by 2 sig figs. Your final answer now is 1.8 times 10 raised to 22 formula units of C8H9O2N or acetaminophen. Okay, we have here 2 significant units. Again, make sure to follow the correct rounding off numbers.